In this video, I'm going to show you how to derive Bayes' theorem, and then in the next few videos, I will show you how to apply it. So let's say this Venn diagram represents a population of people who likes apples and who likes bananas. So if you're in this region, you like both apples and bananas. So this new notation, what is the probability of A happening given, so this vertical line here means given B has already occurred. So what that means is, if I were to pick out a person at random from our population, you're given that this person already likes bananas. So it's going to be over 5. The whole population is 5. And then what? So you know that this person already likes bananas. What is the probability of this person also liking apples? So you can see, you've got to look at the whole population of 5. And then within that population, you're looking at this region here. So it's 2 over 5. So this new notation of ours is actually 2 over 5. Now, I want to show you that when you come to read Bayes' theorem, you've got one probability divided by another probability. What does that even mean? So let me try and explain this. So if someone asks you, given that B has occurred, what is the probability of A happening? So it's the same thing, but I want to show it to you from a different perspective. So up here, you can just glance at the Venn diagram and see that, B occurring is 5, and then you can just look at this region of apples, so that would be 2 over 5. You can just glance at this and see part divided by the whole, part divided by the whole population. Now let's look at it from a different perspective. Looking at this, B happening, well, what is the probability of B happening? Well, it would be probability of B happening, and you divide it by, well, you get the population of apples. So population of the probability of A and B. So this is another way of looking at it. So this region here is A and B, and this region here is just B. Probability of B. Now up here we didn't even look at probability, because probability is something over the whole population of, in our case, of 6. So what is the population here of B happening? It is, so this block here, just this block here would be 5 over 6, because the probability of B happening is 5 over the whole population of 6. Now, this thing here, probability of A and B is 2. But the when it comes to probability, it would be 2 out of the whole population of 6. You see, up here, when we did this, we can just glance at this and see, oh, it's 2 over 5, given that B has occurred. It's 2 over 5. But now we need to read it in terms of probability. So, this thing here is given by A and B, which is this thing, and then probability of B, which is 5 over 6. Now, when you come to tidy this up, 2 over 6 divided by 5 over 6, which means times the reciprocal of the second, times 6 over 5. Cancel these two out, it becomes 2 over 5, which is the same as up here. So when you come to do this thing here, you can just glance at this Venn diagram and see, oh, it's 2 over 5. You can just glance at it and see it. But I want you to be able to read it in terms of probability of one probability dividing by another probability. So A and B, which is this region here, divided by probability of B, which is this whole thing here. So in terms of probability, where you have over 6 over 6, it still works out to be the same thing. So when it comes to probability dividing by another probability, it still works out. So now let's try and understand the Bayes' theorem. So hang on. So when it comes to Bayes' theorem, you've got your Venn diagram A, B, given probability of A happening given that B has occurred. This is equal to part, so that's a probability of A and B divided by the whole thing, which is probability of B. Now let's look at it from the perspective of this circle now. So I'm trying to derive this formula here. So probability of B happening given that A has occurred. So now I'm using this circle to derive a similar thing to up here. So you would get probability of A and B divided by the whole population here, A, because you're given that probability of A occurring. So here A has occurred, so your whole population is A. Okay, so now times this to both sides. So that would then give me, I would take this down. Probability of B happening, given that A has already occurred, times this thing here, probability of A equals this thing here. So, hang on, A and B. So this thing is the same as this. I've just multiplied this to this side. So let me just erase this. And again, I'm trying to derive Bayes' theorem here. So now you can see that this thing here is exactly the same as this. Look, these two are the same. So I can just put the whole thing into here. So let's take this down. Probability of A occurring when given that B has already occurred equals, don't forget this is the same as this. So I'm just going to put the whole thing here into here. So that would be probability of B happening when A has already occurred, and then you times A, and then this thing here would be over probability of B. So that is Bayes' theorem there. This is Bayes' theorem. Now, at this moment, this thing here means nothing to you at the moment. When you see lots of examples, then it will make sense. Okay, so my next step is to give you some examples. Okay.